So welcome everyone. We have a very large number of participants for this course today. And we kick off this special course on which is titled Astronomical Data Analysis using Python. This is the first lecture of this series. So what is this course all about? So first of all, there are no real strong prerequisites for this course. We don't expect you to have a previous programming experience, but conceptual understanding will be easier if you have some prior experience programming in another language. We will be providing all the slides that we use in these lectures, as well as edited videos via YouTube. If you're a beginner and you find the pace of the course to be too fast, and this will happen to you surely if you don't have programming experience in any programming language. I will try to explain all the jargon, programming jargon that we use, but it may well happen that I may forget to mention something. In that case, I request you to review the slides as well as the talk videos periodically, so that you are up to speed with all the concepts that we have covered. Starting with the second lecture onwards, we will provide you with code snippets, which are little pieces of Python code, often only 3 or 4 lines long, but you are encouraged to use that code, practice it, try to make modifications to it, and see what happens. Given the large number of participants that we have in this course, I will only take questions from the participants for a few minutes at the end, but we have a mode of interaction through the Moodle forums. So those of you who have not yet registered participants for this course, who have not yet created your Moodle account, please do so at the earliest. And the Moodle forums give you a platform for asking questions about the material that's covered in the lectures. And I encourage you to ask questions there, because we won't be able to take too many questions after the class. And you might think of a question once you start trying out the code yourself. You'll think of something to do. Some of your questions could be easily answered by actually trying it out. Okay, so when we start sharing the code snippets with you from the next lecture onwards, please, if you have a question, what will happen if I do this? Please just do it and check it out for yourself. So you don't have to necessarily ask people. What I will teach you in this course, so this course is going to be about 10 lectures of about an hour each, and we will have at least 2 tutorial sessions. Depending on, so these tutorial sessions will be based on the assignments that we will give you. And the plan is to give you 2 assignments. The first assignment will be to test your conceptual understanding of the Python programming language. And the second assignment will be to test your ability to use Python to analyze some astronomical data. But we will have one tutorial a few weeks after we give you each of these assignments, so that we can work through the problems in the assignments with you and help you clear any conceptual or other difficulties that you may have in solving the assignments. In addition to that, if there are a large number of questions that remain unanswered in the Moodle forums, or if we feel that there is some benefit to having an online session, we may organize 1 or 2 additional sessions where we will basically respond to questions that have been received from the on the various forums. So this is the rough organization of the course. The course will have 6 lectures on the core Python programming language. It will have It will have one lecture on how to use Python for numerical computing. It will have one lecture on how to make figures and plots using Python. And it will have two lectures, which will be astronomy data specific, which will talk about what are the Python tools that are available specifically for astronomical data analysis. A bit about myself. I am presently a faculty member at the National Center for Radio Astrophysics of the Tata Institute of Fundamental Research in Pune in India. I taught myself Python in late 2001. So it's been 2 decades since I learned Python. And I did this when I was a postdoc. I've used Python extensively for astronomical data analysis for about 18 years now. And I've also taught an introductory Python programming course 4 times between 2009 and 2014. And this course represents my 5th attempt overall, but my first attempt to teach Python programming entirely online. I'd like to acknowledge contributions of 2 people. The first is Dr. Kaustubh Wagmare, who you see here on the left. Kaustubh has played a role in the previous 4 iterations of this course. He was a student the first time I taught it, but the next 3 times that I taught it, Kaustubh was an active co-lecturer in the course. And many of the concepts and the slides that I will use during this course were prepared by Kaustubh during previous iterations of this course. Of course, I've gone and modified them and changed them quite a lot, but the origins lie in the organization and in the slides that Kaustubh had made for some part of the course. The second person is Dr. Pritish Mishra. Pritish was my former student at NCRA. He's now a postdoc at IUCAA. And Pritish is going to help out with conducting the tutorials. Pritish, during his thesis work, has learned and used Python very, very extensively. So he'll be able to give us perspectives, not just from the point of learning Python, but also using Python for real-life astronomical data analysis. So a little bit of philosophy, how we are going to approach this. The ultimate goal of this course is to introduce you to astronomical data analysis using the Python programming language. But due to the limited contact hours in this course, we will take the most direct path to the ultimate goal. This implies that I will have to consciously ignore most aspects of the language that are not relevant to data analysis. So as we shall see soon, Python programming language has 2 parts. One is the core Python programming language, which we will cover in reasonable detail. But there is a vast landscape of additional Python packages that allow you to use Python to do a variety of tasks. So we will not cover those packages in any detail, because we are going to be focused on trying to use Python for astronomical data analysis. Having said this, I will say that only the final 2 or 3 lectures are going to be focused on specific usage of Python in astronomical data analysis. If you intend to use Python for data analysis in other domain areas, and it's being widely used in very large number of different domain areas within science and engineering, but also outside of it, much of the course will still be useful to you, because we're going to cover things in as generic a manner as possible until we get to the final data analysis part. Another caveat I must point out is that the usage of Python in the last 3 or 4 years particularly has exploded in the field of data science. So data science means the use of artificial intelligence and machine learning technologies to solve real life problems. And in almost any domain area that you can think of, AI, ML are being used nowadays, and the bulk of the usage is coming through programs written in the Python programming language. However, in this course, we are focused on data analysis and not on machine learning and AI, and therefore the packages and the software that is related to AI and ML will not be covered in this course. Another generic statement I want to make is that programming is a craft. It requires doing. It requires practice. So if you just learn a programming language from a course or from a textbook or somewhere else, if you don't use the programming language, your knowledge of it will rust away. So given the number of participants in this course, so the last few times when I taught the course, we used to have about 50 participants in the course. Now we have more than 350 participants. In such a situation, it is impossible for me to push you towards practicing the codes that you are supposed to learn. So the responsibility is entirely on you. I expect each one of you to practice Python programming, and my job is to guide you on what to learn and in what order to learn it. But the actual learning is your responsibility. As I already said, from the second lecture onwards, we will start sharing with you all the code that we use in class. Please use it to clarify your understanding and to practice your skills. After the course is over, remember this is a short course of only about 10 lectures. There is much that we will not be able to cover in this course in this short time. So after the course is over, please continue to study the codes that we give you. Please modify other codes that you will find on the internet, and then start to write your own. The first step in learning a programming language is to read other people's code, try to understand it, try to modify it to your purposes, and so on. But the ultimate goal is to write your own code independently of everyone else. So that you should try and start doing as soon as possible. There is no shortcut to writing good programs. Only through extensive practice will you be able to learn the art of Python programming. We expect you to have a computer or access to a computer, maybe a desktop, it may be a laptop, it doesn't matter. And you need to get Python installed and running on that computer. If you happen to run the Linux operating system, it is almost certain that Python is already installed on your machine. You just have to type Python at the command prompt in a terminal and see whether it's installed. It invariably will be installed on a Linux machine. But if you use Mac OS X or Windows, you may have to install Python. And for this, I've given a link here on the realpython.com website. Please go to this link and use that. There are very clear instructions on how to install Python on any of the popular operating systems. We don't have the resources to trouble your installation problems. So if you have problems installing Python, then please use Google and online resources to try and debug your problem and fix it. You may also want to consult a local expert if you face any difficulties. Having said this, it's not very difficult to install Python. Millions of people have done it across the world, and I don't anticipate you to have any serious problems. But nevertheless, your immediate next task over the next few days is to get Python installed and ready on your own machine. There is one other piece of software that we will need in our work, and that is the use of Jupyter notebooks. So there is a project known as Project Jupyter, which is run by a group of people called Jupyter Lab. And what is Jupyter? Jupyter is an open source web application that allows you to create and share documents that are very rich. They may contain code, they may contain plots, they may contain simple narrative text. It works with many programming languages. So it's not just you can write a Jupyter notebook that uses R or some other programming language. But of course, it was first created and works widely with Python. We will be using Jupyter notebooks quite extensively in this course. Those of you who have used Mathematica will be familiar with Mathematica notebooks. So the Jupyter notebook idea is very similar. You basically put snippets of code into a cell, and then you run that code. The notebooks for each lecture will be shared with you right after the lecture through the Moodle platform and also through the website. To install Jupyter Lab on your own computer, please follow the instructions which are given at this particular web page. Again, it is not very difficult installing Jupyter, but please do so over the next few days, so that after the next lecture on Thursday, when you receive your first Jupyter notebook, you are able to run the code that's included there. If for some reason you are not able to install Python and Jupyter notebooks, what should you do? There is a fallback option. It is called Google Collaboratory, or Google Collab for short, which is an online cloud-based Python notebook. But this is not the preferred choice. As I said already, try to install Python and Jupyter on your own computer. This will give you the maximum power and flexibility. But if you can't, then you can create your own online Jupyter notebooks using the Google Collab platform. And this is the URL for the Google Collab platform. Needless to say, since it is a Google product, it is well integrated with the other Google services. And you should be able to use this along with your Google account, your Google Drive account, to save any notebooks that you create on Google Colab. You can even upload the notebooks that we will provide for this course into the Google Colab and then modify and run them there. However, remember that Google Colab comes with certain resource limitations. Google Colab will not give you unlimited disk space and unlimited compute resources. So if you want to analyze large astronomical data sets, and in modern astronomy, data sets are invariably always large, it is a better option for you to have a local working installation of Python. But this backup option is just given to you in case you're unable to install Python for some reason, and you want to follow along in this course. Please use the Google Colab platform to follow through with the notebooks that we provide. So why are we learning Python? So Python, as we shall discover, is a powerful general purpose programming language. In spite of it being general purpose, which means it can be used for many things like other languages like C and C++, which can be used for many different purposes. In spite of being a general purpose language, it is quite easy to learn. It has strong but optional object-oriented programming support. If you don't know what object-oriented programming is, don't worry about it for the moment. We will come to it in a few lectures. Python has a very large user and developer community, which is very friendly and helpful. So lots of online forums where you can, even beginners can go and ask questions and expect them to be answered. There is a very extensive and broad library of software which has been created using the Python language. It is extremely extensible, which means Python plays friendly with other programming languages. So it is possible to combine existing C, C++, or Fortran code with new Python code. And you can extend Python with any of these languages, which means you can write code in some code in Python and have it talk to other codes in C and C++ and exchange arrays, exchange data across these programming languages. It comes with a completely free, non-restrictive, open source license. So there's no question of paying anyone any money for using Python. It's all going to be completely free. For all these reasons and more, it is also now the standard scripting language for data analysis. And I'll give you some examples in a minute that is being used very, very widely across astronomy, but also across all other domains. It has now very powerful array processing capabilities. This, of course, is very much necessary if you're processing large amounts of data. And this is done through a package called NumPy. And we are going to have one lecture devoted entirely to this very important package for data analysis. There is extensive documentation available. Many books are there. Lots of online resources are available, both for the core language and the very large number of add-on packages that are available. It has a superb interface to all popular databases. So if you are exchanging information to and from a database table, you'll be able to talk to the database from within your Python program, not only to read data from the database, but if you have the proper credentials, you can even write data into the database. The Python code, as we shall see, is very clean. There are very few non-alphanumerics. So almost everything in the computer program is going to be either a number or an English letter. It forces you to indent your programs. So those of you who have learned programming in some other programming languages, particularly the old Fortran 77, where you actually had to make sure that your core code was indented properly. And there were a few columns at the beginning which were reserved for comments and other instructions, and you absolutely had to indent things properly. With the coming of languages like C, which allowed you to really write things in free form, and the indentation was not really used by the program or by the compiler. The indentation was used only for clarity of reading, and very often people ignored it. In Python, the philosophy is that if your program is not clear to read, it should not run correctly. So taking this basic idea to some say extreme limits, Python forces you to indent. Indentation is the only way to separate different blocks of a Python program. We'll of course encounter this very soon when we start doing loops and so on. But this is there. So if you've not programmed in any other language, this probably is not going to be a worry for you. But if you have, you will have to unlearn some of the bad habits that you may have formed while programming in other programming languages. Python is very concise, it's very small. You can often do things in a few lines, 3 or 4 lines that may take 30 or 40 lines in other languages such as C or C++. Python codes are very readable and therefore they're great for large teams. It is very easy for you to write a Python program and then go away and then somebody else to read your Python program and make further modifications to it. Plotting in Python is quite easy, and it's very easy if you know MATLAB, using a package called matplotlib. And again, we are going to have one lecture devoted to how you can make plots using Python. If you are into development of graphical user environments, GUIs, then Python is a very good language for doing that. It supports many different widget systems for GUI development. There are a number of other advantages to Python, which I have not listed. And that is because, again, we are not thinking in terms of Python, the whole scope of Python and its use across various domains. We've only listed things that may be quite relevant for our purposes. What are the disadvantages of Python? So it's very hard to make this slide. So some of these disadvantages you will find later on are quite contrived. So for example, there are more items to install separately. So when I say you go and install Python, you will just install the core Python language. If you need to use any of the other packages like NumPy or matplotlib, which we just mentioned, you will need to install these separately. But this is eased greatly by pre-packaged distributions. So there is one very popular one called Anaconda. That is a Python distribution that bundles together not just core Python, but some of the most widely used packages. And so if you install Anaconda, you will get NumPy and matplotlib and a whole host of other packages installed with that distribution. There are also, in all operating systems, there are package management tools where they make the job easy. For example, on Linux, there is the apt tool on Debian-like distributions. You can just do apt install python-numpy, and NumPy will get installed. So it's not, again, it's not terribly difficult. It's easy, but only if you know what to do. There are lots of online resources. You can Google it. Some specialized scientific libraries are not as stable or fast as they are in Fortran or C. But many Fortran libraries have been wrapped. So if you use, there's something called the NAG library, which is used for numerical computations. It's available through the NAG interfaces package with full access to its mathematical and statistical routines. IMSL is again a very popular library. IMSL routines are also accessible through a wrapper, which is called the IMSL Python library. You will get a little bit confused about the array indexing convention that is used by Python. It's different from what is used in Fortran, and because some of the some of the original implementations of data storage formats, like the FITS format for images, was implemented using the Fortran way of arranging things, there will be a few problems that you will encounter when you start using Python for data analysis of two-dimensional data. And we will, of course, explain to you what those problems are and how to avoid getting confused. Python was not originally designed for operating on large arrays or even small arrays, and the performance with arrays is used to be very, very slow. And this is now greatly eased by this new package, or not very new package now, somewhat old package called NumPy. And using NumPy, it becomes possible for you to analyze data at speeds that are not quite as fast as Fortran or C, but very, very close. So the convenience of having Python as your preferred programming language greatly outweighs the slight slowness in speed that you will encounter when using it in place of Fortran. The popularity of Python is exploding. So I made this plot on the Stack Overflow website, and I chose 5 programming languages which are quite popular at the present time: Python, C#, JavaScript, Java, and C++. And what is shown here on the x-axis is time. We are going from the year 2009 to the present time. And what is plotted on the y-axis are the percentage of Stack Overflow questions per month that were received on the Stack Overflow. And as you can see, the blue line, which is the line for Python, has been steadily climbing since about 2013, and now exceeds the second most popular language, JavaScript, by some margin. So about 1/6 of the questions that are asked on the Stack Overflow website, which is one of the most popular websites for answering questions on programming, Python is the #1 sought after language. Of course, this is not a metric of, this is only one metric that you can have. You can have other metrics. One metric that you can have is job openings. So a few days ago, I went to this popular Indian job site called Naukri.com, and I typed in a search for Python programmer. So it's now showing me jobs for Python programmer, and as is highlighted by that little red rectangle at the center, there were 95,386 jobs available. So you can see here that clearly Python is a very popular language, not just among scientists, astronomers, and so on, but also amongst developers in the commercial software world. But what about Python users in astronomy? So if you take Python usage in optical astronomy, it has been quite popular. One of the most popular data reduction softwares for optical astronomy and near infrared and mid infrared data is the IRAF software. And IRAF has been wrapped so that you can use IRAF routines, IRAF codes from within a Python program, and that is done by STSCI in the form of a piece of software called PyRAF. Similarly, ESO has had its own code called MIDAS for their data analysis, which has been wrapped with PyMIDAS. Then there is something called AstroWise, which is a wide field imaging system. There is a code called FM, which provides you ephemeris for solar system objects. That has been wrapped via PyFM. So by installing PyFM, you're able to access any solar system ephemeris from within your Python program. New telescopes which are being built are using Python extensively in their entire software stack. So for example, the LSST survey that is being done, going to be start in a few years by the Rubin Observatory, uses Python and C++ extensively within their software stack. If you look at the scenario in radio astronomy, the most popular new radio astronomy data analysis environment called CASA has had for the last many years a Python interface called CasaPy. The underlying routines are in apes++, basically they're in C++ code. This is the default system for EVLA and the ALMA data analysis. and many Python data reduction pipelines for different radio telescopes across the world use CASA. So for example, for our very own GMRT telescope, there are now CASA-based pipelines that are available for reducing GMRT data, and it's all written in Python. For people who use the older APES software, there is a piece of a software called Parcel Tongue, which allows you to call APES tasks from within a Python program. And using this capability, there is a large Python program called SPAM by Haubintema, which uses Parcel Tongue and generates scripts for automated reduction of legacy GMRT data. For sub-millimeter telescopes, the IRAM data analysis software has been ported to Python. For various control and monitoring systems of telescopes, Python is being extensively used. For example, the Apex control software, as well as the Cat7 control and monitoring software are all written in Python. In more recent times, we've been starting to use Python and the Tango framework for designing and implementing prototypes for the control and monitoring system for the square kilometer array telescope. So it's not just the present day telescopes, but it's also the upcoming future telescopes which are using Python, not just for data analysis, but for even more traditional jobs like control and monitoring systems, which were traditionally written in C or C++, are now being written to quite large extents in Python. If you think of Presto, the popular pulsar search and analysis suite, most recent routines there are in Python. So Python is being used not just for analysis of radio interferometric data, but also in analysis of time series beamformer data from Presto. Why are scientists and engineers excited about Python? It's a full-featured, high-level programming language, which means if you need to learn just one language, then Python is the logical language to learn, because it allows you to do many different things, and it's a high-level programming language. Recognizing the role of Python in education, there is a national mission on education through information and computer technologies. This mission sponsored a large program to develop computer education materials in Python for school and college students. And I've given the website there where you can go and look at the very large content that they have produced through this project. It has very powerful text processing capabilities. Many sysadmins who were previously using Perl or Bash have switched over to using Python because of this. Powerful interfaces to almost any database. So invariably, lots of websites which use a lot of data in order to present to the users. They invariably use Python to talk to the database to make plots and then render them for the users. It's a web-friendly language. Many packages are available for controlling, managing websites and accessing content on these websites. It has very good numerical computation capabilities, as we shall see later on in this course. It has very, very fine plotting capabilities. And of course, as I mentioned earlier, today it's the most popular language for researchers working in the field of artificial intelligence and machine learning. But our course, remember, is focused on using Python for data analysis with a special emphasis on astronomy. So let me speak a little bit about where you can get additional learning resources. So books obviously are a good choice. if I searched for Python programming on the books section of Amazon.in, and I did this a few days ago, it shows more than 7,000 books are available. Many of these, not all, are beginner level books. So if you want to purchase a book, exactly which one you choose will depend on your learning style and personal preferences. There are books that aim to teach you Python very, very quickly. So those are little thin books which can be read through in a few hours. But there are also thick books, reference manuals, which give you all the gory details of all that you can do in Python. So I won't make any specific recommendations. Please go check out the reviews of the various books, find a book that you like and read it. Many of the most popular books have gone through multiple editions. So since Python has changed from Python version 2 to version 3 quite significantly, I urge you to go and purchase the most recent book version of these books. You don't have to buy books necessarily because there is a lot of material that's available online, both in terms of detailed descriptions of the software, the various packages that are there in Python, but also tutorials, okay, and also lots of online forums for solving problems. So the first place you should go to is www.python.org, which contains a very large amount of resources. They have a nice Python tutorial, which is available at this URL. We will cover all of it and much more in this course. So you can start with it, but if you're doing this course, you don't really need to go through the tutorial. There are SciFi conferences. So SciFi is one major package of Python, which allows you, it's called scientific Python. The SciFi people organize conferences periodically, and this is again the URL. There are lots of interesting talks, many with video versions that are available for the annual SciFi conferences that have been organized for the last several years. So if you are the kind of person who likes to learn by watching a talk or a presentation or a demo, then please head to the SciFi Conferences website. There are also excellent Python programming courses on Coursera and EDX platforms. Also, several other new platforms have come up, which I'm not familiar with. But on all of them, you will find lots of excellent Python courses. Some of them are basic courses. Invariably, these days, when people say that, let's teach you programming from basics, they tend to start with Python. But there are also more advanced courses in these platforms. There are also lots of good videos on YouTube. I was really pleasantly surprised when I was doing a search a few weeks ago that there's a lot of nice content on YouTube that explains Python, often with short 3 or 4 minute long videos. They explain some concept in Python, very useful. Then Stack Overflow is a very, very popular website where users can pose their questions and other users come in and answer those questions. So if you are, you need to be, of course, very courteous and very precise when you frame your question. Also let people know what all you tried to do to solve your problem. And then you're very likely to, within a few hours, get an answer or sometimes multiple answers, multiple ways of resolving your problem. Very, very useful website, not just for beginners, but also for more advanced Python programmers. The python.fossee.in website, which I had shown in a previous slide, also has a very large number of short tutorials on Python programming. Okay, so Python version 2 or version 3. Two major versions of Python are in widespread use. Python 2 and Python 3. And each of these two major versions has many different subversions in use. For the purposes of this course, we will exclusively use Python 3. And we are doing this because all major data analysis related packages have now been ported to Python 3. They've been tested extensively and are now very stable. The last time that I taught this course in late 2014, this situation was not there. Many Python 3 ports had not yet happened. Those that had happened were not as stable as the Python 2 version. So at that time, we had used Python 2 while teaching the course. But now I think the situation has changed. There is no longer any justification to use Python 2. We will be using Python 3 exclusively. Traditionally, when you start programming in any language, the practice is to write a short hello world program just to announce yourself that, look, I've arrived and I'm saying hello to the whole world. In Python, the process of writing such a program is very simple. If you're using Linux or even Windows, just type Python -C, and within these single quotes, just write print hello world, and it will print it out for you. Okay, very, very straightforward, not complicated at all. So if you want to start the Python interpreter, you could simply type Python at the command prompt. In my case, I type Python 3, but that's only because I have both Python 2 and Python 3 installed on my machine. So to avoid confusion, I type Python 3 explicitly. But if you have only one version installed, and that is Python version 3, which we are going to use in this course, simply type Python, and that should show you a prompt. And what is that prompt? The prompt is are these 3 lines that you see at the end. That is the Python prompt, and it basically is telling you, okay, now give me a Python command, and I will execute it. And of course, it tells you what version of Python you're using, as well as which version of the GNU-C compiler was used in order to compile the Python interpreter. There is, in addition to the standard Python interpreter, there is an enhanced Python shell, which is called IPython. And again, instead of typing Python at the command prompt, if you type IPython or IPython 3 in my case, it again gives you a prompt. And the thing to notice here is that the prompt is slightly different from what we got for the standard Python interpreter. IPython is mentioned here because it is the shell for several astronomy data analysis packages. CasaPy and PyRaf both use IPython as their standard shell for executing Python commands. Jupyter notebooks, I'm going to skip this now because we will use this in our course. I was going to do a demo, but we are running a little late. So I will give this demo at the start of the next class. Okay. Programming language flowchart. So this is an interesting flowchart that I found on this website called zappable.com, and it basically guides you to what programming language you need to learn. And there if you follow the sort of flowchart, you will end up with Python. If you want to learn a clear and general purpose language, which can do almost everything, and you work for your own. So, I mean, you get here by, do you work for a big company? If it's yes, they'll probably want you to learn a compiled language which has more rules, it prevents errors, runs faster, etc. But if you're working on your own, it's better to learn an interpreted language which has less rules and lets you code small tasks very, very quickly. So that is the idea behind learning Python. And of course, there are many competitors: JavaScript, PHP, Ruby, Objective-C, C, C++, and so on, which you can use if you have purposes different from what we have in this course. If you start Python and you just type import this and press the enter or return key, you'll get this particular text. And I'll go through this text because this text encapsulates very well the philosophy of Python. Beautiful is better than ugly. That's easy to understand. Explicit is better than implicit. What this means is that if you want the code to do something, it is better to specify it explicitly than assuming that since it is the default, that is what will happen anyway. Because that obfuscates the code, makes it harder to read. Simple is better than complex, of course. Complex is still better than complicated. So when you write a code to solve a particular problem, if the problem itself is complex, the code will be complex. But it should never be complicated. It should never be difficult to understand and very convoluted in its logic. Flat is better than nested. We will encounter this sentence when we do the NumPy module. Flat is better than nested. I'll leave it at that for the moment. Sparse is better than dense. Okay, better not have your logic written in such a way that it's very, very dense, and therefore readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. So you have to get the problem solved. You try to do it so that you don't break the rules, but don't be focused on the purity of your code. Your code has to work and it has to solve the problem at hand. Errors should never pass silently unless explicitly silenced. Which means if there's an error in your program, it should get caught. And if it gets caught, something should be done about it. You may decide that, okay, this error is not affecting anything else downstream in my code, and I'm just not going to do anything about it. You're going to just pass over it. But it should then be explicitly silenced. It should be a conscious decision to not interfere. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably one, obvious way of doing it. Although that way may not be obvious at first unless you're Dutch. Okay, this is a reference to the creator of Python, Guido van Rossum, who is a Dutch computer scientist, and therefore what is obvious to him may not be obvious to you, but since it's obvious to him, he has implemented it in Python. Now is better than never, although never is better than right now. Okay, so sometimes you should do things quickly. But if you try to do things too quickly, you may make mistakes. So that's why often never is often better than right now. So don't make mistakes that mess up your code. Take your time, take a little few days and solve the problem in the correct way. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Okay, it's not necessarily a good idea, but it may be. Namespaces are one honking great idea. Let's do more of those. Again, this is something that I will explain later on in the course. So in Python, so this is a cartoon with which I will end this first lecture. It's called that Python feeling. So there's a person who's flying in the air, and the person on the ground is asking him or her questions about what they've done. And the claim at the end is that the Python is allowing them to fly. So I will stop here. I see lots of messages in the chat. And let me go through that, and we can also have a few questions. Yes, somebody says that I think that Kaggle or Google Colab notebooks could be used if installing Python is a problem. Absolutely. One can use the default ID that Anaconda supplies even for Linux. Spider, it serves the purpose well on your local system and less boring than the terminal. I agree to that, but my response to that is we are not going to use the terminal in this course. We are going to use Jupyter notebooks, which are all pre-written. ID can be used in place of Jupyter notebooks, but Jupyter notebooks are easier because what I'm doing in this course is I'm creating a single notebook, and from that notebook I'm creating PDF slides as well as notes for you all. So it's just a matter of convenience. IDs can be used in place of Jupyter notebooks, but I think given the cloud-friendly nature of Jupyter notebooks, they're much easier to share. So if you're writing code that only you will use, by all means use whatever ID you like. Right. So there is some people are recommending PyCharm as an ID. Yes, that is also, I used to recommend that previously. Is better, somebody says is better than Anaconda Navigator. That may be true. But again, for the beginners, my recommendation is that don't spend too much time on exactly setting up your system and getting the best possible integrated development environment working on your system and so on. Just start writing. Yeah. I have SciSoft installed in my machine. This makes it complicated while installing Jupyter. Okay, fine. In that case, you can use the Google Colab option that we suggested. I'm not well versed with Linux. Windows is okay. Yes, absolutely. Everything that we will do is doable in Windows. Python runs as happily in Windows as it does on Linux. You will see a certain bias towards Linux because I have used Linux almost exclusively since 1994, which may be before some of you were born. So forgive me if I talk of Linux all the time, but that's just because of my preference. You can use Mac OS 10 or Windows just as well.
Hello.
Yes, please go ahead.
So, hello, Yogesh. I want to ask Jupyter Notebook and Jupyter Lab. These are both are different thing, or the Jupyter Notebook is the part of the Jupyter Lab? Because nowadays I am
So
reading
there is,
that
yeah.
everyone moving towards the Jupyter Lab rather than the Jupyter Notebook.
Jupyter Lab so there is something called Project Jupyter, which runs the Jupyter Notebook as one of its projects, and it runs a few other things. So there is no difference. I mean, there is a difference in the nomenclature, but there are not multiple softwares. Jupyter is only one. So if you install Jupyter, whether you install Jupyter Lab or Jupyter, it will give you the same thing.
Thank you, Yogesh.
Only the interface is slightly different. So
yes. But I think now the new thing is called Jupyter Lab, if I'm correct.
So now
It used to be
everyone
called
knows
just
about.
Jupyter in the old days.
As far as I
And
understand,
the whole thing started as something known as IPython notebooks, which was 5-6 years back. But now this whole Jupyter thing has taken over, and it's yeah. Go ahead, please.
sorry, I was just saying all of this is fundamentally the same technology, except the interface is slightly different, and it might give more features. Some of them.
Yeah, yeah, yeah. And they're also nicely interoperable. So the format that Jupyter uses for the Python notebooks is the .ipynb format, which stands for .ipython notebook. So you can, for example, take our notebooks and upload them into Google Collab, which is a cloud-based Jupyter notebook, and it runs quite happily on that platform. I have confirmed that by loading the notebooks that I've created onto Google Colab. Similarly, you can download notebooks from Google Colab that you created on Google Colab, download them to your machine, and open them using the local Jupyter installation that you have on your machine. So it's all quite nicely interoperable. Sometimes you may have trouble reading and writing files, but in 99% of cases, it should be possible for you to move files from the cloud platform to your local machine and vice versa, quite interoperable. So would we get a chance to do some projects in astronomy data analysis in this workshop? So not really, because the way we have designed this workshop is that it's very generic. The course is very generic. It will guide you to how to use Python for your own data analysis. And the hope is that if there are 350 participants, each one of you will come up with your own research projects. So there should be 350 research projects that emerge out of this course. And then I think the course is successful. For importing data from data sources like SDSS or SOHO, how exactly we proceed, and are we going to do such exercises? So you will have exercises that will be based on analysis of certain popular data sets like SDSS, but obviously we are not here to troubleshoot every problem. Everything that you have asked, that the questions have been asked so far, everything can be done with Python. That is for sure. Whether we will teach you exactly how to do it in this course, I'm not so sure. So we will give you a few exercises where you will have to download data, then you will have to read the data into a Python program. You may have to make some plots from that data and so on. So all that will be done, but the specifics of how to use it on your radio astronomy interferometric data, or your SOHO data, or your SDSS data, or something else, that we won't have time to go through. But if there are some generic questions that appear in the forums where everybody says we really want to do this, we will do one of two things. We will either include that kind of question in the assignment so that we can discuss it in the tutorial, or we will have this special discussion session where we will take up questions that are asked in the forum, and if one particular question is asked by many people, that surely will be answered in that forum discussion session. Yes, somebody says that they wish there was some on ML2. We consciously excluded ML from this because this is a course focused on data analysis. Perhaps in the future, we can have another course which is focused on the use of Python for artificial intelligence and machine learning applications. So Python for data science, as they call it nowadays. We'll have to do a separate course. No way to fit it into a basic course which starts from scratch and goes all the way there. Thank you. Somebody says I have both Python 2 and Python 3 in my laptop. Now I installed Jupyter Lab. When I open Jupyter Lab, only Python 2 is shown. Why is it so? In the Jupyter Lab, there should be an option of changing the kernel. So what I request you to do is just Google and figure out how you can change the Python kernel that you are using in your Jupyter notebook. You can use either the Python 2 or Python 3 kernel if you have both of them installed. Are there any other quick questions or there are 2 new messages? Yeah. Somebody asked, does Google Colab support all modules of Python? So all the modules that we will use in this course, including the popular AstroPy module, which is used mainly by astronomers, is supported and installed in Google Colab. I've verified this by going to Google Colab and doing an import AstroPy there, and it works. So, if you have Google Colab, you will not need, for the purposes of this course, all the modules that are needed, NumPy, SciPy, AstroPy, Matplotlib, etc., are available in Google Colab.